Hi, I'm an old guy and I do maths. This was planned to be part of a much longer video on solving simultaneous equations by elimination, but I thought it might be a bit overwhelming, and so I've split it into two. And this is the second part. There's a video on the channel about the basic use of elimination to solve simultaneous equations. This video will look at a couple of slightly more complicated examples. And so, what have we got here? Well, we've got two equations. Y minus 3x equals negative a half, and x plus 2y equals 5 over 2. Right, so what am I going to do? Well, I'm going to get rid of the fractions first. Okay, so I'm going to multiply this by 2. So this becomes this, 2y minus 6x equals negative 1. And I'm going to multiply through by 2 here as well. And that's going to get rid of this fraction here. So x plus 2y equals 5 over 2 becomes 2x plus 4y equals 5. Now I notice that I've got this equation in this order. So I'm just going to swap the positions of x and y here so that this equation is in a similar order to this. Hopefully you can see that. Okay. And then I'm going to look at how I eliminate. And I've set this up as my top equation, 4y plus 2x equals 5, which is what I got from here. And I've put this equation below it. And 2y minus 6x equals negative 1. Everything lines up. And what I want to do is I want to get rid of the y's. I've decided that I want to get rid of the y's. So in order to do that, I'm going to multiply this line by 2. Okay, so initially I multiplied by 2 to get rid of the fraction. Now I'm multiplying up to make this expression here equal 4y. And you can see the result of that here. I've done nothing to the top. I've multiplied the bottom by 2, and 2y minus 6x minus 1 has become 4y minus 12x minus 2. And I'm going to subtract to eliminate the y's. And when I do that, I get 2x minus negative 12x gives me 14x, and 5 minus negative 2 gives me 7. So x is equal to a half. Okay, we've got one of them. Now, we're not going to go through the whole process again. What we're going to do is we're going to substitute in. And we're going to substitute in using this equation here, which is probably about the simplest one on the page. We're going to substitute in the value of x, which we know, to find y. Right, so let's get to it. So this is y minus 3 times a half, which is our x value, and that equals negative a half. So y minus 3 over 2 equals negative a half. What I do to make life easier for myself is I simply add 3 over 2 to both sides of this equation. So if I add 3 over 2 to this side, this disappears. And if I add 3 over 2 to this side, I get plus 3 over 2. And that tells me that y is equal to 1. That is 3 over 2 minus a half, or negative a half, plus 3 over 2. It equals 1. And that is the point at which these two lines would intersect on a graph. It is where the two equations are equal to each other. When x equals a half, y will equal 1 in each of those equations. Right. Let's try another. So again, this is elimination, and I've left a few blanks in here so that you can see some of the working. We've got two equations, 8x plus 3y equals negative 13, and 5x plus 4y equals negative 6. Now, there's no easy way to getting these things to equal each other. So what I've decided to do is I've decided to make the y's equal each other. Now, to do that, I've got 3y here. So what I'm going to do is I'm going to multiply the bottom by 3 and the top by 4. And as long as I'm multiplying everything in here by 4 and everything in here by 3, I will maintain the ratios within these equations. Okay, so what does that give me? Well, the top line gives me 32x plus 12y equals negative 52. 3 times this gives me 15x plus 12y equals negative 18. And what I want to do is I want to get rid of the 12y, so I subtract. 32 minus 15 is 17. These disappear. Negative 52, effectively plus 18, gives me negative 34. X is therefore equal to 2. 17 times 2 is 34. 17 times negative 2 will give me 34. Right. And now I just sub in. It's the old story of subbing in. Now, I'm subbing into the top equation. So 8x plus 3y equals negative 13. Right. And I already know what x is. So here goes. So 8 times negative 2 plus 3y equals negative 13. So 16 plus 3y equals negative 13. Now if I add 16 to both sides, I get 3y equals 3. Negative 13 plus 16 is 3. These two numbers disappear. I'm left with 3y equals 3, and therefore y is equal to 1. So the solution for this pair of simultaneous equations is x equals negative 2, y equals 1. And again, if you were graphing them, this is the point on a Cartesian plane where these two graphs would cross. Thanks very much for watching. See you next time.